Hello and welcome to another Common Core Geometry lesson by eMathInstruction. My name is Kirk Weiler and today we'll be doing Unit 4, Lesson number 6 on the inscribed circle of a triangle. Now a few lessons ago we did a lesson on the circumscribed circle of a triangle. This is another lesson where we explore the interesting relationships between triangles and circles. All right? So let's get right into what an inscribed circle is. All right, here we go. Every triangle has a circle that can be inscribed in it such that the circle is tangent, and we'll talk about exactly what that looks like in a minute once my picture comes up. So a circle that is tangent just touches each of the three sides. So here I've got this triangle, right? And I've got a circle with tangent points E, F, and G. These again are points where the circle touches the triangle but doesn't cut through it. That's the idea of a tangent. Tangents are amazingly important. And again, just like the circumscribed circle, there is only one inscribed circle for every triangle. Let me play around a little bit with the Geogebra widget right now, okay, and show you kind of the way that looks. Okay, just like with the circumscribed circle, if I take point C and I kind of move it around, you can see certainly the size of the circle changes, all right? But always those points then are tangent, just touching the sides of the triangle, all right? The question is, how do we construct that circle? Now, a little bit of a comment up front. This will likely be the most challenging construction that we do in this course because it's got quite a few steps. So the key here will be, as much as possible, trying to understand the steps of the construction. All right? Memorizing them step by step becomes kind of tricky, although you certainly can. All right, but as best as possible, try to understand what's going on. So let's dive right into it. All right, easy problem first. Which of the following diagrams shows a circle inscribed inside of a triangle? This should be pretty easy. Yes? Choice 3. Again, the idea here is that when a circle is inscribed inside of a triangle, it must lie entirely inside of the triangle. But then again, this circle would lie entirely inside of the triangle, and that's not inscribed. It has to lie entirely inside of the triangle, and then it must intersect each one of the three sides just once at these things called tangent points. Tangent points. All right, so we got to be able to recognize it, and now let's construct it. I'm kind of curious to see how close I can get with this construction. I almost never get it perfect, right? But we'll see how good we can get it. Let's take a look. Exercise number 2. Given triangle ABC shown below, do the following. Letter A. Construct the angle bisectors of angle A and angle B. Label their intersection point M. All right. Now, in the last lesson, we looked at how to do angle bisectors, so hopefully they're fresh in your mind. But what I'd like to do is do the angle bisector for A so that we can very quickly review how to do that, and then have you do it for B. All right, let's go through it. Now the angle bisector is going to be extremely important in this construction of the inscribed circle. So make sure you remember how to do it. I put the center of an arc at point A, and I draw the arc so that it intersects the two sides of the angle. I then move my compass and put the center of an arc at one of those two intersection points. Typically I have to then make the radius of the compass a little bit bigger, and I draw an arc. I want to get that as close as possible. Any little kind of mistake here, and the construction will be much worse. All right, don't change that radius. Put the center of the arc at the other intersection point. Draw, and X marks the spot. Let me bring down my straight edge now. Hopefully you had your straight edge already. And let's draw in that angle bisector. Okay, what I'd like you to do now is pause the video and bisect angle B, make sure that that bisector is long enough that it also intersects this bisector. Go ahead and do that. All right, let's go through it. Let me see how quickly I can do this. I still want to have it pretty accurate. Rotate my compass back up, bring it over, put the center at B, come on. There it goes. Draw that arc so that it intersects twice. Bring it over like this. Let's see. Oh boy, maybe I should have changed the color. I'm gonna expand this a little bit so that they intersect a ways away from where the others intersect. There we go, that's a lot better. Okay, there's one arc. Now let me bring it up here so that it's on there. And I think I'll just kind of bring it down. Did I get it? I did, just barely. But I did find the intersection. Let me bring this over here. I really gotta rotate my ruler quite a bit. Ooh, and I guess throw it all over the place. Here it is, almost on point B. Got it. Rotate this down and draw that angle bisector. All right, let me get rid of the ruler for right now, but not lose it too much. Now I'm going to put that point there, and it says, label it as M. Great. That is a very important point. In fact, this probably won't come as any great surprise to you. That point is going to be what's called the in-center, or it's going to be the center of the inscribed circle. Now, when we did the circumscribed circle, at this point, once we had the center, it was very easy because we just sort of put our compass at that center, expanded it out to one of the 3 vertices of the triangle, and drew that circle around the triangle. This one's not going to be quite so easy, all right? So, before we get into what we do next, let's talk about letter B. Explain why M must be equidistant from all 3 sides of the triangle, okay? From all 3 sides of the triangle, not from all 3 vertices of the triangle. Why does M have to be equidistant from all 3 sides of the triangle? Pause the video now and see if you can give an explanation for this. All right, let's go for it. Here it goes. Let me make this a little bit thinner so we have more room. Great. All right. Okay, because M lies on the bisector of angle A, it is equidistant from side AB and side AC. So remember that from a previous lesson? It was actually from the last lesson, okay? Which is that any point that lies on an angle bisector is equidistant from the 2 sides of the angle. So right now, I know that M lies equidistant from AC and AB. Likewise, it is equidistant from AB and BC, right? Likewise, right? Why do I use the word likewise? I use the word likewise to basically be shorthand for exactly the same reason. Again, it's exactly the same reason, right? This is the angle bisector of angle B, and therefore any point that lies along here, including M, must lie equidistant from the sides of the angle, i.e. AB and BC. But that means if I'm lying equidistant from AC, AB, and BC, I'm equidistant from all 3 sides. Okay, let's continue with the construction. Letter C. Construct a line through M. Let me bring this back up. Construct a line through M that is perpendicular to AB. Mark the intersection of this line with AB as point D. Explain why the length of DM represents the radius of the inscribed circle. All right, well, we'll worry about that explanation in a bit. Let's talk about the further construction we have to do. I now have to construct a line segment that passes through M that is perpendicular to AB. And we did that construction a few lessons ago, specifically in a lesson entitled Constructing Perpendicular Lines, right? And one of the constructions was, when I have a point and a line, and the point's not on the line, how do I construct something that goes through this point, right, that is perpendicular to this line? Well, let me do this. Let me change the color of everything to red to do that construction. And let's remember how to do that construction. In order to construct a perpendicular line through a point to a line segment, what I need to do is I first need to draw an arc. Maybe expand this down. I need to draw an arc whose center is at M and that passes through AB. Now, just like me, you can kind of take your compass and you can kind of experiment with it, right? That would do the job. I think I'm going to make it a little bit wider, right? And I can see that, yeah, that arc will intersect AB twice. So I'm going to do it. There we go. Intersects AB twice. Okay. Once I've drawn that arc that intersects AB twice, right, then I know that these 2 points, one there and one there, lie equidistant from M, so M lies on the perpendicular bisector of the segment that runs between those 2 points. I just need to find one other point that lies on that perpendicular bisector, so let me bring my compass with me. That was fun. Bring my compass with me. And now what I'm going to do is I'm going to maybe make the radius of the compass much smaller, but I'm going to draw an arc down here, take my compass, move it over here to that point, come back up, and I want to draw this arc as well. Wow, nice. And now let's connect M. All right, there's my 0 point. Let's connect M with that other cross right like that. All right. And I'm going to mark this point as something. What did I say? I think I said it was D. Yes, D. Point D. Now I claim that that will now be the radius of that that inscribed circle. Okay? And the problem asks me why that should be. So remember, at this point, we know that M lies equidistant away from the 3 sides. Why should that then be the radius of the inscribed circle? Well, it's pretty simple, right? dm, that doesn't look like a D, it looks like a P. dm is the radius because it is the shortest distance from D to AB. Remember, the shortest distance from any point to a line segment is the perpendicular distance from that point to the line segment. So now, let's see how good of a job I did. If I did a good job with my construction, and that really is 2 constructions at once, then what will happen is that when I draw a circle with that center and that radius, it should be tangent at 3 points and not go outside of my triangle at all. Wow, that was kind of fun. There we go. All right. Whew. Well, how good of a job did I do? So-so, right? Number one, I kind of missed point D altogether. I guess it kind of migrated up there. Definitely pretty close there, and not so close there. All right. But again, that's okay, right? This is a very, very challenging construction, and little tiny, like a 1/2 millimeter here, a 1/2 millimeter there, will make all the difference in the world. Again, very easy if you're using something like Geogebra, not just easy, but I mean, it'll nail it down perfectly, all right? But this is the longest construction because you have to construct 2 angle bisectors. Where those angle bisectors meet is definitely the center of your circle, all right? Then you have to construct a perpendicular line from that point to any one of the 3 sides. I just chose this one because I thought it would be the easiest one. And then the length of that segment then becomes the radius of that inscribed circle. All right, well, let's keep going. All right, and actually, let's take a look at how nice it looks on GeoGebra. Watch how fast and nice it works on here. Okay, so in this particular GeoGebra demonstration, I've got triangle ABC as always. Okay, and what I'm going to do is I'm going to ask it to create the angle bisector, somewhere, there it is, the angle bisector of angle BAC. Then I'll ask it to do the angle bisector of CBA. I'll then ask it to find the intersection point of the 2. That is my in-center, or the center of my circle. Now, unlike again when we did the circumscribing circle, I can't draw the circle right away because I still need to do a perpendicular line. So I need to say, all right, take this point and draw a line perpendicular to it. I also actually have to still have it find the intersection point. But now this is the center of my circle, and line segment DE is the radius. I've really got everything I need. I'm going to say, hey, draw a circle with that center, and goes out to that point, and take a look at that, right? We've now got this beautiful inscribed circle, and no matter how I then draw this, right, that circle stays inscribed. It never goes outside, and obviously does a much, much better job than what I did when I was doing it by hand. And of course, that is the advantage of kind of computer software like this, is that there's no slipping of the compass or anything like that. One-day standardized exams, when they're actually given on computers everywhere, and I know some of you probably already take them on computers, those in New York State don't quite yet, hopefully you'll be able to do constructions like this instead of like this. Don't get me wrong, I'm still partial to these, but the computer-generated ones are sort of awesome. Anyway, let's keep going and get some more practice. Okay, whew, this is a long construction, right? Exercise number 3. For triangle DEF below, construct the circle inscribed by the triangle, or inscribed in the triangle, either way. Leave all construction marks. Label the center of the circle point C. All right, well, we went through the construction, we went through it fairly slowly. So what I'd like you to do now is pause the video for as long as you need to, go through the construction. Again, don't worry if it's not quite right. I guarantee when I go through it in a minute, it won't be quite right. And then we'll kind of move on to one last one. But take a few minutes now. All right, let's go through it. Step 1, 2 angle bisectors needed in order to find the in-center. So I'm going to bisect angle F. Yep, that'll work just fine. Immediately the thing moved off of F, which is problematic. Ugh, and it's just not on F. Anyway, already my construction is probably a little bit off. Let me move my ruler up here. Make this a little bit longer, maybe even a little bit longer. And make this arc. Move this over to here. Make this arc. Get rid of my compass for the time being. Bring my ruler down. X marks the spot. And let's draw, make it worse than it already is, Kirk. Ooh, red. Okay, I'll take it. Probably didn't need to, but somehow it turned red. Love it when my pen does that midstream. All right, I'm gonna go back to blue. All right, so now let's, yeah, I think I'll bisect angle D. Why not? It's right here, so put the tip at angle D, bring it back. Let's Draw an arc through there. Let's now bring it so the tip is out there. Maybe make it a little bit bigger, see if that's going to get the job done. I think it will. So make my arc like that. Bring this one to here. Again, let's do another arc. Wonderful, they cross. Bring this back. And rotate on D. All right, my other angle bisector. And where the two intersect is right there. All right, that will be the center of that circle. Okay, now what I have to do is I have to choose a side. Okay, and I have to construct the perpendicular line that goes from C down to that side. That side could be DE, it could be DF, it could be EF. I think I'm gonna construct it perpendicular to DE. All right, so I'm gonna bring this thing up like this. DE is a nice long side, kind of get this thing over here. Remember, I have to have an arc that passes through this thing twice. It'd be really nice if this thing could just stay at the center. Again, it's really amazing because if this is off even a little bit, it becomes problematic. All right, wonderful. I've got an arc now that intersects that circle twice, here and here. All right, I will now use those 2 points to locate another point. Stretch this out a little bit, rotate. Oh man, it's going to be right near that thing. Hopefully not right on it, but if it is, it is. Not quite. That's good. There it is. There's my X. Get rid of this. Bring this up. Rotate around. Again, in theory, what I'm now doing is I'm creating a line that is passing through C that is perpendicular to this side length. That actually looks pretty good, okay? And the point now is that that little segment right there is going to be the radius of my inscribed circle. So I bring my compass back, set my center there, set my radius to be the length of that segment. Oh boy, moment of truth. Oh, close. All right, I came very, very close, obviously here. Not bad here, and you know, there I missed just a bit. All right, but overall, not too bad, my inscribed circle, right? Again, quite a few steps. Angle bisector, the intersection is then the in-center, the center of the inscribed circle. Then draw, or construct, sorry, a perpendicular segment from that center to any one of the three sides. They'll all be the same length because the point is the in-center is equidistant from the three sides. All right, then use the length of that line segment as the radius of your circle. Whew. Wow, you might have to watch the video multiple times just to get those steps down. All right, but let's take a look at one last one. When you have an isosceles triangle, you can make it a little bit faster. Okay, so let's do one final one like these, but with an isosceles triangle. Okay, so a triangle with two sides of the same length. Let's take a look. Given isosceles triangle below where EF is congruent to EG, do the following. Construct the inscribed circle, label its center point H. Now again, I'd like you to work on this yourself, but I want to give you a piece of advice before you do so. See, my natural kind of inclination would be to say, well, I'll bisect that angle and I'll bisect that angle. I'll bisect the two base angles. With an isosceles triangle, you can make your life a bit faster if you first bisect angle E, or the vertex angle. So do this, okay? Just do this. Pause the video now. Bisect angle E and either angle F or G, you don't have to do both, and find the center and then stop. And I'll explain why. Okay, take a few minutes to do that. All right, let's go through it. So first things first, I'm going to bisect the vertex angle. Okay, and that's going to take a little work because I have to kind of do this with my compass. That's okay. Open it up. All right, and I'm going to now draw a nice arc there. Okay, I'm now going to come down like this and maybe make this a bit wider. Draw an arc there. Bring it over here. Switch, come all the way around. And there. Bring this thing down. And draw that. Okay, so I just bisected the vertex angle. Okay, now let's bisect angle F. That's the one that I'm going to do. So I'm going to bring this down, rotate this up, make my compass do some irrelevant things. All right, bring this over to point F. Nice arc there. Bring this out to here. Stretch open my arc some. See, will that get the job done? Yes, it'll be very close to the other one though, so just so it's not quite so visually confusing. Great, then it intersects that other arc. Go kind of like this. Switch. And just gotta remember what arc is what, right? And what X is what, so to speak. Here we go. Let me rotate this up. I gotta make it go through that X and F. That should be good enough. Wonderful. So this now is the center of my inscribed circle. Now here's why I suggested bisecting the vertex angle. And this goes back to something very special about isosceles triangles. The angle bisector of the vertex angle happens to be perpendicular to the base. So at this point, normally what I would do is I'd take that center and I would construct a perpendicular line segment to one of the three sides. But the key is, by bisecting the vertex angle, I already have a segment that is perpendicular to one of the sides, so I can just use this as my radius. All right, so I'm going to take my compass and I'm going to set my radius to be this length. Hopefully, I'd like this one to be as accurate as possible. Come on. Like one to be decent. Moment of truth. Again, not too bad, right? Pretty much on the mark. A little bit outside here and pretty much right on the money there, and ironically a little bit outside there. All right, but easy enough. Now real quick, there's a little bit more in this problem. It says mark the tangent points of the circle and EFG as I, J, and K respectively. All right, draw in triangle IJK. So in theory, let me kind of get rid of this because we don't need those circles there. These circles at least. In theory, this would be a tangent point, this would be a tangent point, and this would be a tangent point. Real quick, let's connect those. Why don't you go ahead and connect them at the same time that I am. All right, there we go. And then I think what we'll do is we'll bring down our 0 mark here. I'll label them as I, J, and K in just a moment. Kirk, use your rotation a little bit better. There we go. Rotate up like that. All right. Let me get rid of this guy. We'll call it I, J, K. It doesn't really matter which way you label it. And then final part of this problem, letter C, describe a rigid body transformation or a rigid body motion or a rigid transformation, lots of different ways to say it, that can be used to justify that triangle IJK is isosceles explain. So what do you think? What could we use to justify that the triangle that we just drew, IJK, is isosceles? All right, let's talk about it. We can use a reflection. And there I go back to red, a reflection across line EK, right? So if I reflected triangle AJK across line segment EK, and here comes the reflection part, the explanation part, get out of here, then K maps to itself and I and J map onto each other. Since reflections don't change distance, actually maybe I'll say length, don't change length, that means that IK must be congruent to JK. All right, a little rigid body motion work. We haven't seen that since Unit 2. Whew, talk about a construction, right? Couple angle bisectors where they intersect, finding the center of that incircle, then using a perpendicular line construction if necessary, because we didn't need one in this case, right, to determine the radius of that circle, and then drawing the circle in. All right, let's wrap up the unit. Not the unit, but at least the lesson, although it's almost the unit. We have only one more lesson in Unit 4, in constructions. We'll see some other constructions later on in the course, but we want to build up the content that we'll need for those. In this particular lesson, we saw the most challenging construction we'll see in the course, which is how to take a triangle and draw a circle inside of the triangle that's tangent to all three sides of the triangle. It just touches the three sides without going outside of the triangle. All right? This involved the angle bisector construction and the perpendicular construction from a point to a line segment. Two different constructions needed to be used to create this greater one. All right, and that's why it's pretty complicated. Make sure to watch the video and the steps as many times as you need to in order to get this construction down, all right, and be adamant about working on the homework. All right, for now, I'd like to thank you for joining me for another Common Core geometry lesson by eMathInstruction. My name is Kirk Weiler, and until next time, keep thinking and keep solving problems.